Welcome back. In this lesson, we're going to be looking at syllabus point A1.1.7 Describe internal and external types of secondary memory storage. Now, you already looked at primary memory storage, which is basically RAM, ROM, cache, registers, and so on. And these are all directly accessible by the CPU. Secondary memory storage, on the other hand, is not directly accessible by the CPU. Data or instructions from secondary memory storage have to be transferred into RAM for the CPU to be able to access them. Therefore, most of the time, secondary storage is used for long-term storage and retrieval purposes. Often, when we want to transfer data from one computer to the other, we can use portable secondary storage devices as well. So what exactly is secondary memory? How do we define it? Well, secondary memory, also sometimes called secondary storage, refers to non-volatile, long-term data storage devices that retain data even when the power is off. The key is non-volatile. That means they will not change their data, they won't refresh it, they won't reset it when the power is off. Now, it complements primary memory by storing the operating system, application, and user files over time. Now, this data will need to be loaded into RAM for the computer to be operational. However, you want to make sure that because RAM is volatile, when we turn the computer off, whatever is saved in RAM is transferred into secondary storage first before the computer is turned off. So secondary memory devices are typically categorized as internal, which means they're inside the computer system, or external, which means they're plugged in or networked. We're going to be looking at the most common ones. So let's start by looking at the hard disk drive, which is an example of an internal storage device. This is the most common, or used to be the most common form of storage. It's magnetic, so therefore it uses electromagnets, and it stores data on platters, which are basically disks which rotate, and each platter will have its own read or write head. Hard disk drives are normally found in desktop computers, some old laptops, and of course servers. They have very high storage capacities and are very reliable, but they can be comparatively very slow for data access. Often data is accessed between 100 megabytes per second to 200 megabytes per second. They are more susceptible to mechanical failure as well, since they're mechanical devices and they have a lot of moving parts. However, they offer excellent cost per gigabyte value because they're cheap, but they are physically bigger, they're slower, and they're vulnerable to shocks. So if you drop a hard disk drive, chances are you can end up damaging it. The second type of internal storage device we're going to be looking at is the solid state drive. Now, these can also be external, but we're just going to be focusing on the internal part for now. These use NAND flash memory, so there are no moving parts. So this uses the same technology that might be in a RAM chip. They have faster read and write speeds than hard disk drives. They're often found in modern laptops and smaller devices because of their form factor. They have very high performance, they're more durable, they're more energy efficient, and they significantly improve boot and loading times. So they're ideal for operating systems and high performance needs. However, they also have some disadvantages. They are more expensive than hard disk drives, and their reliability over the longer term is still being proven. Often you'll be asked to compare hard disk drives with SSDs in an exam question, so make sure you know what the factors are. For example, access times, latency. SSDs are faster, they have low latency, they have no moving parts. Hard disk drives, on the other hand, can have greater storage capacity, they're cheaper, and the similarities are that they both are non-volatile in nature, so they retain data without power. I will recommend that you look at how each of these operate in a bit more depth. However, the points that have been listed on screen are the common ones you need to remember for exams. The next device we're going to be looking at are embedded multimedia cards. This is a type of flash storage often found in many low to mid-range devices. It integrates the multimedia card interface, flash memory, and flash memory controller on a small package on the device's motherboard. While eMMC is solid state and it offers significantly improved performance compared to HDDs, it is generally slower than most SSDs, especially in terms of sequential read and write speeds and input and output operation. eMMC storage usually offers lower capacities than SSDs, but it is less expensive. Its lower cost makes it an attractive option for manufacturers if you are producing budget-friendly devices. Now, it also uses NAND flash memory technology. It offers fast data access speeds, it's highly reliable, it's relatively shockproof. However, it does have disadvantages. It's more expensive than the hard disk drives, and it offers comparatively lower storage spaces. And the final one is the upgradability. Because they're soldered onto the motherboard, eMMC cannot be upgraded. Now, these are the only three internal storage devices that you need to know about. Let's start looking at external storage devices. Now on screen you see the most common ones that we need to know about. So let's start with external hard drives. These can be both SSD or magnetic HDD. External hard drives come in a variety of sizes and capacities, and they can be used for backup purposes, transferring files between computers, or simply storing data. The functionality of an external HDD or external SSD is the same as the internal HDD and SSDs. So make sure that you are talking about the same type of things like access time, mechanical parts, and so on. Next is the USB flash drives. These are small, removable solid-state drives for convenient file transfer. These are slower than SSDs, but very, very portable. To use them, you need to plug these directly into the computer's USB port. Make sure that you don't mention them as USB in the exam because USB is normally a technology, universal serial bus. The USB port is a platform or interface where you plug in a USB device. So this device's name is a USB flash drive. A lot of students lose marks by simply calling it USB. Now these are very cheap, they're affordable, they use NAND flash memory just like any other solid state device. The advantages of flash drives include portability, fast data transfer speeds, and affordability. The disadvantages include lower storage capacities, and they can be susceptible to data loss if not properly handled. Losing a flash drive can present a security risk, especially if confidential data is stored on the flash drive. Okay, next are memory cards, SD cards, or micro SD cards. These are normally used in phones, cameras, and some laptops for lightweight storage expansion. These also come in a variety of sizes and capacities, and they're very useful for transferring files between devices and for backing up data. They also use NAND flash memory, so they are solid state devices. Their advantages include portability, compact design, and of course storage capacities. However, they can be lost or damaged easily and may not be compatible with all devices. Optical drives were once a common type of external storage. However, they are now being superseded by SSDs. They're still very useful when you want to archive huge amounts of data or perhaps use legacy software. How do they work? Well, they store data as tiny indentation known as pits, which are encoded in a spiral track on the round disk. The area between the pits are known as LANs. So the process of reading writing data involves a combination of optical technology, digital encoding, and the physical structure itself. The advantages of optical drives include high storage capacities and compatibility with older devices. However, they have slower data access speeds and the disks can be fragile and susceptible to scratches and dust. Now, optical discs come in three different flavors: CDs, DVDs, and Blu-ray. CDs and DVDs use a red laser, whereas Blu-ray uses a blue laser. Blue laser basically has a small nanometer length, therefore you can store more data on the same size disk. So CDs are the smallest in size, normally 800 megabytes. DVDs can go up to 4.7 GB or higher if you use dual layer DVDs, and Blu-ray discs can go into tens of gigabytes, 25 to 50 GB. And finally, there's network attached storage, also known as NAS, and these devices provide centralized storage for multiple devices on a network. NAS devices are typically connected to a router and they can be accessed by any device on the network. These are ideal for sharing files, backing up data, and storing media files. And most of the time, NAS uses hard disk drives and solid state drives, or a combination of both. These can be configured with RAID, which stands for Redundant Array of Independent Disks. And the reason we do that is to protect data against drive failures. So what happens is that there are multiple drives, and if one fails, data is already backed on the second one, so the server can serve the data to the client. Now, NAS can be easily expanded by adding additional hard drives to accommodate growing data needs. The benefits of NAS include centralized storage, shared access for multiple devices, scalable storage, and a high degree of control for system admins. The disadvantages of NAS devices are that they are more expensive than individual external devices, and they require configuration and require a network connection as well. Okay, that's all for external storage devices. Now, of course, you can go into the operations side in a bit more depth. That's what the books are there for if you're interested, but generally, you should be able to structure answers for full marks very easily with what we've talked about. Now, in addition to knowing what these devices are, you need to know how and when they can be used. In an exam, you'll probably be given different scenarios and you would need to recommend a storage device and justify why it is suitable for that particular scenario. Some of the common ones are on screen, so let's go through them. Scenario, high speed, boot and performance. For that, you would recommend an internal SSD. Why? Because of faster access times and low latency. If you have large scale media backup, you would probably recommend an external HDD or a NAS device. Why? Because they're cheap and they will have huge capacities. Low cost portable storage, these can be flash drives or memory cards. Again, portability is the key factor. Budget mobile devices, eMMC devices, due to their form factor and low power consumption. Shared home and office access, for that you'd probably use a NAS setup. And again, it's the network part that will be justifying this particular device. Installing legacy software, you'll probably use optical drives of older technology and compatibility. Of course, there are going to be other scenarios which aren't listed here, but it's up to you to justify them based on your knowledge of storage devices. Now on screen, you'll see key terms which are relevant to this particular section. Do pause the video and make sure that you understand them and jot them down in your glossary. That's all for this particular lesson. Hopefully you should be able to answer questions like these. What's the main difference between an SSD and HDD? In which scenario would an eMMC be more suitable than an SSD and why? What is NAS used for? Why are optical drives less common today? Which storage type would best suit a video editor working on large files? Remember, these type of scenarios can be given to you in an exam, and chances are that the scenario you see in an exam has never been covered before. So make sure you understand how these devices operate, what their advantages and disadvantages are. That's all for this particular lesson. If you do have any questions, please get back to me in the comments. Otherwise, I'll see you in the next one.